almost done a few more. Let's look at this fraction. So it's kind of a division problem. So before we do anything, let's simplify it. So the 2 and the 6 play together. That's 1/3. Then your underneath play together. So 8 and 12. If you've got 8/12, divide them both by 4. That's 2/3. Then, thank you. Okay, your x is on top and x is on bottom. If you've got x2 on top, that's just like expand it, and I got 3 on bottom. X divided x is 1, x divided x is 1. So that simplifies to just square root of 2 on top, and on bottom 3 square roots of 3x. Okay, now can't have an irrational on bottom, so let's times this by 1. The one you need to choose is whatever this radical is. So I'm going to times the bottom by square root 3x times the top by square root 3x, and in front of here they're just 1's. So the outsides times together give you 1, the insides times together, 2 times 3 will give you 6, and then you got an x. Then on the bottom, outside is a 3, outside is a 1, so 3 times is the 1, creates a 3. And then the underneath times together, 3 times 3 will give you 9, x times x gives you x squared, and that is a perfect square. So your numerator is square root of 6x, your denominator is a 3 times square root of 9 is 3, and square root of x squared is x. So your denominator is 9x. No irrationals. Everything is legit, nice and rational. Okay, an addition problem. You got negative 3 squared to 6 plus 2 squared to 5. Okay, 6 is done. A 2 and a 3, but only singles, no doubles. So that is simplified as far as it'll go. 5 is done. 20 is not. If you bust up 20, 20 will simplify to a 4 and a 5. 4 is a 2 and a 2. So don't forget this minus out front. Minus square root 20. You got 2 squared times 5 to the 1. So the square root is going to undo that square, so 2 is now out with the negative. And 5 stays in. And that is going to be a like term with the middle term. So now I've got a trinomial. I've got 3 pieces. And this middle term and this term, these are like pieces. So we're going to add these together. And if I got 2 squared root of 5 minus 2 squared root of 5, that is 0. So those will combine together, give you a 0. And this out in front is a negative 3 squared root of 6. And that is your answer. Alright, now you got another division one, but this one's much more complex. So you can't really change this. You're kind of 5 dividing by both of these terms. So this one on top you have just a one monomial, and on bottom you got a monomial, one thing on top, one thing on bottom. On the bottom of this I have 2 terms. I've got 3, and then I got square root of 10. So I have got to multiply this by 3 minus square root of 10. E2. Okay, times the top by 3 minus square root of 10. Now, here's what's going to happen. If you start distributing, so these are called conjugates. If I got one that is a plus and one that's a minus, it's going to create a nice 0. So 3 times 3 on the bottom, that creates a 9. Then if you do 3 times a minus square root 10, that's minus 3 square root 10. And now let's distribute the square root 10 to the 3, and that's a plus 3 square root 10. And let's distribute the square root 10 to a negative square root 10. That's negative square root 100. So right here is your 0. You got negative 3 square root 10 plus 3 square root 10. That will create 0. And you got 9 minus the square root of 100. That's just 10. So on bottom, you've just got a negative 1, which is nice and rational. Okay, now your top. Square root of 5 times 3. That is 3 square roots of 5. And square root of 5 times a minus square root of 10 is a minus square root of 50. And that has a square in it. So if I bust up 50, so 50 is going to go to a 25 and a 2. And 25, that is a 5 and a 5. So 50 really has 5 squared times 2. So that square root's going to undo the square. So 50, instead of 50, let's go minus 5 square roots of 2. And this is your answer. Okay, now you got I to the 73, so we'll do the Jake. So if you ever have an I times an I, if you ever have an imaginary times imaginary, it's real and it is negative. So if I have like I times I times I, that's a real, but that's an imaginary, so you got a leftover imaginary, so it's negative imaginary. Now if you got 4 of them, I, that's a negative 1, that's a negative 1. So the outcome's a positive 1. So if you have an even amount of imaginaries, it's always going to create a real, but it creates 2 types of reals, either positive or negative. So if you have a pair of I's, it creates a negative. If you have 2 pairs, it creates positive. So I've got 73 of them. Now 73 is this odd family right here, so you're going to have one that's left over. If you have an odd amount of imaginaries, it is going to remain imaginary. So here we go. I'm going to look at it as like 72 and 1. So here is my leftover right here. This is what's going to make it imaginary. So Jake says this, every 4 imaginaries is positive, so he is wondering if there are an even amount of 4s in 72. So if we just do 72 divided by 4 on your calculator, 72 divided by 4, that is exactly 18. So that comes out an even amount. That means this is a positive 1 times your leftover, and that equals I. So now if you got 258, so it's even. If it is even, it is going to be real. So you got 2 options. You're either going to go plus 1 or you're going to go minus 1. So if we do kind of the same thing, every 4th one's positive. So if I do 258 and I tried to divide that by 4, see if 4 goes into it evenly. It goes 64.5. So I know that it's going to be a negative. Okay, now here's the other. Yeah. You guys are the only class we did that with, so we're in business. Okay, let's look at this guy right here. What 2 complex numbers have a sum of 6 and a product of 34? So if we look at the factors of 34, you can create a 34 by 1 and a 34, 2 and a 17, and that's it. So which numbers will sum to give you 6 but times to give you 34? So none of these real numbers are going to work, so we're going to use a combination of a real and imaginary. So they've got a sum to give you 6. and it's going to be this. We're going to use conjugates. So we're going to use 3 plus some imaginary and 3 minus that same imaginary. Because when I add them up, if one of the imaginaries is positive and one's negative, that creates a 0. 3 plus 3 creates a 6. So now when I multiply them, it's going to be 3 plus something I times 3 plus something I. Now when I start distributing, because anytime you times two conjugates, two complex conjugates, they will always create a real number. So I start to distribute 3 times 3, that's a 9. Okay, now 9 is kind of a key number. I need to end up at 34. So if I take 34 and I minus the 9, these guys have got a times to give me 25. And so I have found it. If I've got to multiply to get 25, I know one of them is going to be 5i and one of them is going to be minus 5i. So let's try that. So if we go 5i, one needs to be plus, though one needs to be minus. So 3 minus 5i. So there we go. 3 and 3 gives me 9. 3 and a minus 5i gives me minus 15i. 5i and 3 gives me a plus 15i. 5i and a minus 5i gives me a minus 25, but I gives me a minus. So there we go. That's a 0. 9 plus 25, that is 34. So I found them. 3 plus 5i is 1, 3 minus 5i is the other. Okay, now this guy right here. You cannot have an imaginary on the bottom. You need to multiply it by 1, but because I've got two terms here, I need to multiply it by the conjugate. So I'm going to multiply by 2 plus 3i. So times the top by 2 plus 3i. Now if we start distributing, 4i times 2 is 8i. 4i times 3i. 4 times 3 gives you a 12. But I times I creates a negative. Now on the bottom, 2 times 2 creates a 4. 2 times 3i creates a 6i. Minus 3i times 2 is a minus 6i, and that's a 0. And a minus 3i times a plus 3i, minus 3 times 3 is a minus 9. I times I is a negative 1. So negative 9 times negative 1 turns it positive. So on the bottom, I've got 4 plus 9. Those are gone. So I got 13. So on the bottom, I got 13. On the top, we go negative 12 plus 8i. That's it. There we go. Okay, now 1 plus I cubed. You have to expand it. So it is going to be 1 plus I times 1 plus I. 3 times 1 plus I. 1 times 1 creates a 1. 1 times I creates an I. I times 1 creates another I. I times I creates a negative 1. And this is nice because 1 and a negative 1 is 0, and I is 2i. So I'm going to take the result of those first two, which is 2i, and times it by 1 plus I. So now I times that to that, 2i, that to that, and I get a minus 2. So if you put the real part first and the imaginary part second, minus 2 plus 2i is your answer.